All right, now let's look at problem 8. So in this problem, we practice little algebra. So here we have two equalities. So the first one, we have x plus 2y plus 3z equals to 25. So we don't know what they are, but we have these two relations. So 3x plus 2y plus z equals to 35. The question from here, can we deduce what is x plus y plus z, right? Okay, all right. So what we're going to do is do some we just do some massage. You know, we have two equations. Let's say we can do the addition or subtraction, whether we can get x plus y plus z, right? All right. So that's the quickest way, right, to do it. All right. Okay. So when you look at this, you say if I add them together, right? So if I add them together, okay. So this add together, this give me 4x. This add together, this is 4y. This add together is okay, so this is 4z. And here, of course, we need to add both the left-hand side and the right-hand side, right? So this one you add, okay, so this equals to 60. You say, wow, this is great. So I get a 4x plus 4y plus 4z equals 60 after I add the two things together, right? Okay, all right. So from here, I get a 4 times, here we, as I said, when the letters are involved, we often omit the multiplication sign, all right? So, okay, I pull the 4 to the front, then I add the bracket. So it's x plus y plus z equals to 60. So I get x plus y plus z equals 15, right? 60 divided by 4, which is 15, all right? Okay, so this is what we do is we basically do some algebra. We add these two things together, right? If the right-hand side equals to the, if the left-hand side equals the right-hand side, then if you add them together, of course they're also the same, right? Okay. So this gives us a quick way to figure out x plus y plus z. All right. Now let's look at the number 9. So number 9 is a problem about the probability. So as we said before, right? So if we have only finite many scenarios, then the probability is essentially just a fraction. So it's the total number of cases divided by the total number of scenarios, right? Okay, so for here, the problem says a bag, right? So a bag has 5 balls, right? Have 5 balls. 3 of them are red, so 3 red balls and 2 blue balls, right? And 2 blue balls. Okay, Leo randomly picks 2 balls, so randomly picks 2 balls, right? 2 balls. Then what is the probability he gets 2 balls of the same color? Okay, all right. So let's apply the formula. So the formula says, what's the total number of cases? So first, let's calculate the denominators. The number of total. Maybe I say the number of all situations, all scenarios, all cases. If we just choose 2 balls, right? Okay. Now you have a 5 ball and you choose 2 ball, and how many different combinations do we have? Later on, like if you get deeper into the subject of counting problems, you will know something called a combinatorial, and we have efficient way to calculate that. But for here, let's not worry about those advanced tools. We just calculate by hand. We just count by hand, which is kind of primitive, but it's enough for our purpose. Okay. The total number of cases, we say, all right, so let me redraw these 5 balls, right? So let's count it just one by one. So I have 1, 2, 3, 4, right? So this is 4. And then I have 1, 2, 3, right? So plus 3, okay? So then I have, from here, so I have 1 and 2, right? So I have plus 2. Let me use another color. Let's say this one, okay? So also I can do this combination, right? So you just plus 1. So in total we have 10. So there are 10 different total number of scenarios, right? So it's 10. Okay. So total number of cases is 10. All right. So then let's figure out the number of valid cases. So for our problem, the valid case means they have the same color, right? So it just means has the same color. 2 balls have the same color. Okay. So then clearly we have let's see. what we're going to do is 1, 2, 3, right? So this is 3, right? So we should need 2 red balls, or you just do two blue balls, right? Two blue balls. So this is, okay, so this is 1. All right, so then you have it's 3 plus 1, right? So it's 3 plus 3 plus 1, which is 4, right? So those are the valid cases. Okay, now we just plug those things back to the formula. The formula is, as I said, is a fraction. So it's the number of valid cases, which is 4, so right here, and the number of odd cases, which is 10. Okay, so it's just 4 divided by 10, and that is 2 over 5. So this is the probability. All right. So as I said, keep this in mind. What is probability? In the classical setting, probability is just a fraction, right? It's one fraction of the whole thing is those scenarios that we are looking for, right? So here the whole thing is I just randomly pick out 2 balls with all the possible combinations. So that's the order case. And what I want, what are the valid cases, if I just focus on balls with the same color. So that's what I want, right? So we just look at, okay, what fraction of the whole thing is that part? Okay. So it's fraction. All right. Okay. Now number 10. So number 10 is a geometry problem. So this problem tests 2 things. So number 1 is if I have a triangle, then the sum of angles is always 180, regardless what kind of triangle we have. This is number 1. And number 2 is if I have isosceles triangle, then if 2 sides are the same, then 2 angles are also the same. All right. So here let's review. If I have a triangle, so this is triangle, say it's whatever. So let's say this is 1, this is 2, and this is 3. So the angle 1 plus angle 2 plus angle 3, this is always 180. Okay, so this is a basic fact in geometry. So definitely you should remember. So number 1. And number 2, if I have an isosceles triangle, so if these 2 sides are the same, so this is an isosceles triangle, 2 sides are the same, then implies the angles are also the same. Okay, so same sides corresponding to same angles. Okay, so they keep this in mind. Same sides, same angles. All right. So based on this, we let's figure it out. Okay. So here we have, so these 2 sides are the same. So therefore this angle are also the same, right? So this I get this is 30, right? Go to 30. Now, because this one plus this is 180. So from here, so I get this one has to be 120. And then because this one plus this is 180. So this has to be 60. All right. So same, these sides are also the same. So this is also the same. So the 2 angles must be the same. And you have 60 and with 120, right? You evenly split 120. So you say, okay, so we just get this is 60 and this is also 60. Finally, the angle of this one. So the angle of this, so that's what we want, right? So angle BAC, so this is what we want. So this one equals to 30 plus 60, which is 90. Right? So we get is 90. All right. Okay, problem number 11. So we are looking for 2-digit positive integers that are divisible by 3 or 4 or 5 or both. In fact, here I don't really have to say or both, because if I say divisible by 3 or 4, then automatically it includes the case that is divided by both 3 and 5. Right? But here I just to avoid any ambiguity, I emphasize we also should include the cases both. Right? All right. So here, the thing let's I need to emphasize, if it's divisible. So okay, so a number is divisible by both 3 and 5. This is equivalent to say, right, through and which means it's the LCM. So it's divisible by the LCM of 3 and 5. LCM means the least common multiple, right? All right, so it's equivalent to say the number is divisible by 15. So 15 is the LCM of 3 5, right? So LCM represents the least common multiple. All right. Okay, so now what we need to do is let's count. So if this is a collection of all the numbers divisible by, so this is divisible by 3. And let's say, okay, so I count this is the divisible by 5, right? Divisible by 5. Okay, so then we have, of course, the overlap is the divisible by 15, right? So this is the divisible by 15. Okay, so first let's see those numbers that are divisible by 3, right? So by 3. Okay, so let's look at this part. So this is start from, because what we want is 2-digit. So the first one is 3 times 4, which is 12, and then you all the way to 3 times 33. So that's 99. So here in total you have, so total is 30, right? So you have 30 numbers in this list. Now for 5, if we do a divisible by 5, okay, so 5. So you start from 5 times 2, which is 10, and then you all the way to the last one. So last one is 95. That's 5 times 19. So this is 95. Okay, so here the total is 18, right? Total is 18. Okay, but so you say, all right, so then if you add them together, you say, okay, I add them together. 30 plus 18, which is 48. Well, you might think, oh, okay, so I collect those numbers that divisible by 3 and those numbers divided by 5, and I add together by 48. But 48 is not the correct answer. Why is that? Because they have overlap. When you count the numbers for 3, you count the numbers for 5, the overlap is counted twice. You have to subtract this, right? You have to. The overlap is divisible by 15, so that's the overlap. Okay, so we start from 15 times 1, and the second one is 30, so this is 15. Okay, it's 45, right? So 45, and then you have 60, 75, and you have 90. Okay, so which means you have those numbers here. Let me put it 15, 30, 45, 60, 75, and 90, right? You have 90. Okay, so those numbers are here, and those numbers are also in this collection, right? In both collections. In both collections. So when you add them up, they are counted twice. So you have to subtract them. So here we have 6, right? So here we have 6. So you have 6 of them. So you have 6 of them. All right. So you have to subtract. So the final answer shall be so the answer equals to 48. You have to subtract this 6. So you give us is 42, right? Is 42. Okay. So maybe let me write. So final should be 30 from here, and plus 80 from here. Then you should minus the 6, which is from here. And this will give us 42. All right. Okay. So here the key point is don't forget to subtract the overlap, because when you count numbers divided by 3 plus the numbers divided by 5, the overlap is counted twice, and you have to subtract that. All right. So final answer is 42. Okay. Now let's look at problem number 12. So number 12. So A is the smallest 2-digit number such that the LCM, so it's LCM of A 12 equals to 60, right? So that means first of all, A is 60 is divisible. So from here we get okay. So 60 is divisible by A, right? It's divisible by A. So in other words, A is a factor. So this we say okay. So it's the same as saying A is the divisor of 60, right? So we can look at the divisors of 60. So let's look at divisors of 60, those 2 digits. Those 2 digits numbers, right? So the first one is 10, right? So with 2 digits, 2-digit divisors of 60. So the first one is 10, and then you have 12, and then you have we have 15, right? So we have 15. Okay, so then we have 20, and we have 30, and then we have 60 itself. Okay, so when you check those numbers 10, 12, 15, 20, 30, 60, and you find it's easy to identify 10 is what we want, right? It's the smallest. Okay, so obviously it's the smallest, and meanwhile it satisfies what we want. So LCM of 10 is 12 is indeed 60, right? So we get A is, we quickly identify A is 10, right? Okay, so A is 10. Now we need to figure out how many different divisors of A, okay? So we need to figure out here, right here, it's a divisors of A equals to 10. Well, which is simple, we just let's write out all of them. So we have versus 1, and then you have 2, and you have 5, and 10. So the total number, so the number equals to 4, right? So 10 has 4 divisors. All right. Okay. All right. Now let's look at problem 13. So problem 13. So here we have this is so-called trapezoid. It's called isosceles trapezoid because two sides are the same. All right, so we need to calculate area based on those given lengths of sides. So according to hint, what we should do is we draw the height to the base, and we separate the trapezoid into 3 parts. 2 sides. So here we have 2 congruent right triangles on 2 sides, and in the middle it's a rectangle, right? Okay, so let's look at this. So this is also 4, well, because symmetry, so we have this is 5 and this is 5. Now we need to figure out is the height, right? So this is unknown. Well, how should we do the height? Because this is right triangle, I have 13, I have 5. Now I use the Pythagorean theorem. So let's recall. So we mentioned this before, right? So but let's recall it. So if I have a right, this is right triangle. All right. If I have a right triangle, okay. All right. All right. So then I have this Pythagorean theorem. I have this Pythagorean theorem. All right. So I have A and B and C. So I have C squared equals A squared and plus B squared, right? All right. So in particular for my my example, so what we have is this. So this is 5 and this 13. So what is this guy? All right, so I apply the Pythagorean theorem. So I have 13 squared equals to 5 squared plus this question mark squared. So I quickly grab the question mark. So this is 169 and this is 25. So question squared is 144. All right, so which number is squares 144? Right, we know it's 12. Okay, so I get, so from here I get a question is 12, right? Okay, so this guy is 12 and this guy 12. Okay, so now I can just calculate the area. The area of the middle part is 4 times 12, which is 48, and the area of this one, this is okay. It's 5 times 12 divided by 2, and this 5 times 12 divided by 2, right? Okay, so that is 30. That is 30. Okay, so it's 30, 30, and then it's 48. All right, so then I get the total area. Right? So I get a total area equals to 30 plus 30, and then plus the middle one, 48. So that's 108, right? So 108. So here the key point is, okay, so we separate the trapezoid into 3 parts, and then, but we need to use the Pythagorean theorem to derive the height of this trapezoid. And then we just add the 3 pieces together, okay? It's 108. All right, number 14. So number 14 is that what tank weighs 190 kilogram when it's full of water, and if it's just half full, the total weight is 120 kilograms. So we need to figure out the weight of the water tank when it's empty. Okay. So here the point is the weight when the water tank has water, then the weight consists of 2 parts: the water tank itself and plus the water inside it, right? All right, so let me draw the picture. So say here we have this is the water tank. So at first, when it's full of water, and this is 190 kilogram. And if it's half full, right? So if it's half full, half, so this is full. Okay, so then here we have it's 120 kilogram. Now then obviously you see, okay, this one consists of the tank itself and plus full water, right? And this one consists, okay, so this is the tank itself plus half water, right? Half water. Okay, so obviously, if you take the difference, right? So they share a common thing, which is the weight of the water tank itself. Now, so if you take the difference, so if this one minus, if they subtract this, you get 180 kilogram minus 100 kilogram. What is that? That is exactly half of the water, right? So this is half of the water. So half of water. All right. So this one equals, so we get, so this one, okay, so this is 70. So we get water, the weight minus the full capacity, right? Water. So this is 140. Okay. So we get this one is 140, and this is 190, and this tells us tank is 190 minus 140, and which is 50, right? Which is 50. All right. Okay. So here the problem is you just need to realize there's something which in common does not change. That is the weight of this water tank.